Okay guys, we are going to be talking about matter today. What is matter? Does anybody know what matter is?
Something that takes up space.
Right, it's anything that takes up space. Matter is anything that has mass and takes up space. So can anybody give me an example of matter?
Solid.
A solid would be matter, but anything.
Bed.
A bed is matter, right.
Person.
A person is matter, good.
A rock.
Rock is matter, good. Anything in the world that has mass and takes up space is matter. Okay, there are three main states of matter. Does anybody have a guess as to what one of these states are?
Solid.
A solid, right. Solid is one of them.
A liquid.
A liquid is one of them.
A gas.
And gases are one of them. Good job. Okay, so can anybody give me an example of a solid?
A tree.
A tree, okay, good.
This desk.
The desk is a solid.
Ice.
Ice is a solid, good.
Water.
Water's not a solid.
Oh.
Water would be a what?
Liquid.
A liquid, good. Can you give me an example of a liquid?
Milk.
Milk, good.
Soda.
Soda, good.
Tea.
Tea, good. Good. Can anybody tell me a gas?
Carbon dioxide.
Carbon dioxide is a good one, good. Huh?
Clouds.
Clouds, well, water vapor, yeah. Josie?
Oxygen.
Oxygen, good. One more.
Smoke.
Smoke could be a gas, depending on what kind of smoke it is. Good. Good job. Okay, so what is a molecule? Do we know what a molecule is? Anybody? No, do you know what a molecule is?
It's something real small that you can't see unless you have a telescope.
Right, right. A molecule is the smallest amount of something. It is teeny tiny. You can't see it with your naked eye. Right, good job. Okay, the way molecules move within an object or a substance determines whether it is a solid, liquid, or a gas. Okay? Okay, this is a picture of what particles look like as a gas, a liquid, and a solid. Gas particles move around pretty freely and quickly. Solid state particles stay within the liquid and they move around a little bit more slowly. And then solid particles, they are fixed. They move. If you look at them under a microscope, they look like they're vibrating, but they can't actually get up and move. Okay?
Do you know what water, air, and rocks all have in common? They are made of matter. Matter is something that takes up space. Now, you might be wondering why they all look so different if they are made of the same thing. But the truth is that everything around you is made of matter, just in different shapes and forms. Matter is made of tiny particles called atoms. Matter can be grouped into three main states: solid, liquid, or gas. To figure out which state of matter something is in, we need to examine its properties. A property is the way that something is that we can measure. The physical properties we will look at to determine a state of matter are shape, mass, and volume. Mass is the amount of matter in an object. Volume is how much space that matter takes up. Solids are easy to recognize. Rocks, apples, pencils, and plants are all examples of solid objects. A solid object has a definite shape that doesn't change when you move it or put it in a container. They also have a consistent mass and volume. This is because the atoms in a solid solid object are packed closely together so they do not move around. A solid will change shape only if forced, for instance, if it is broken or smashed. If you look around, you can find many examples of solid objects. Liquid is the next state of matter. Liquids have a definite volume and mass, but they do not have a definite shape. The atoms in liquid are still close together, but unlike the atoms in a solid, they can move around. This allows the matter in a liquid to flow. Because liquids don't have their own shape, they take their shape from their containers. The same amount of liquid may look very different in a glass and spilled on the floor. You can find examples of liquids around you too. Water, milk, and juice are just some of the liquids you might find. The third state of matter is gas. Gases have a definite mass, but they do not have a definite shape or volume. Like liquids, gases take the shape of their containers. Unlike liquids, gases will spread out to completely fill the container they are in. If a gas is not in a container, it will keep spreading out indefinitely. This is because the atoms in a gas are farther apart than atoms in a solid or a liquid, and so they can move freely. The air you breathe is an example of a gas. You might have noticed that you can't really see air. Often, gases are invisible, but they are still there. There are many different types of gases in the Earth's atmosphere, like oxygen, nitrogen, carbon dioxide, helium, and water vapor. Sometimes matter can change from one state to another. Water is a very good example of this. When water is frozen into ice, it is a solid. When it melts back into water, it is a liquid. When water evaporates into water vapor, it becomes a gas. Matter in all its states is everywhere. See if you can find solids, liquids, and gases around you.
Technical difficulties. There we go. Okay guys, our learning objective today is that you will be able to describe each state of matter in its terms of its molecular structure. That means you're going to be able to tell me what its molecules do, okay? So I want you to take out your piece of paper I gave you earlier and be ready to show me and write down a few notes about solids, liquids, and gases, okay? So, a solid is rigid. It has a fixed shape and a fixed volume. That means that it does not change. If I have this spoon, it's going to stay a spoon whether I throw it in the air or if I throw it on the ground and step on it, it's still going to be this spoon. Unless I physically break it, its molecules are going to stay the same, okay? So on your piece of paper, I want you to draw a square. Okay, and then I want you to draw molecules that are closely packed together to show that they cannot move. Okay? And then for a liquid is not rigid. That means that it can be poured out or dumped on the floor. It can move, okay? It has no fixed shape. And what that means is that when I have this bottle of water, the water inside move, okay? Now, is it gonna stay this shape if I dump it out?
No.
What shape do you think it's gonna be if I pour it in this?
Maybe like the top of a square.
Right, good job, good thinking. Let's see. Is it gonna look exactly like this bottle, or is it gonna take the shape of this square?
It'll take the shape of the square.
It took the shape of the square, right? Can you see it?
Yeah.
See? It didn't change in its structure. It's still water, but its shape changed because it took on the shape of its container. Okay, so on your piece of paper where it says liquid, on your piece of paper, I want you to draw a square, and I want you to draw particles that can move. They're not touching. Okay, and draw some little arrows that show that they're moving around within that water, okay? Now, do you think that particle can move outside of the liquid?
No.
No, it can't move outside of the liquid because the particle is inside the liquid. So where you draw your particles, it needs to be inside the liquid. Okay, so then for a gas, its particles are not rigid. That means that they're not fixed. It's not of one particular shape. It has no fixed shape and no fixed volume. Okay? So, an example of a gas would be if I blew into a balloon, is the balloon going to stay flat?
No.
Or do you think it's going to grow and expand?
It's gonna grow and expand.
Right. Good job. So, on where it says gas, draw you a square. And I want you to draw particles that are spaced further apart. And then, does our square have a lid?
No. Yeah.
No, it doesn't have a lid. So, do you think that those gas particles are going to stay in that square? No, because why?
It doesn't have a lid.
It doesn't have a lid. And what do gas particles try to do? The video told us a while ago. What do they try to do?
They try to escape.
Right, they try to expand all the available space. So if we don't have a lid on our box or our bottle that we put our gas in, it's not going to stay there, okay? All right, so we're going to check for our understanding. If you put a gas in a bottle without a lid, will the gas stay in the bottle? No, you're right. No, gas tries to fill all available space so it will leave the bottle, okay? So, is a desk made of matter?
Yes.
Yes, good job. Is rain made of water?
No. Wait. Yes.
Yes. Is the air you breathe made of matter? Yes, that is correct. Yes, everything is made of matter. Everything. Okay? How are the shapes of solids and liquids different? Okay, so I want you to look at your notes and I want you to look at the particles of a solid and look at the particles of a liquid. How are they different?
A solid can't move as much as a liquid, and a liquid can just move all at once, and a solid just has to stay there.
Right. The particles in a solid can't move, right? Anybody else got anything else to?
Gases can move all around when liquids and solids stay in the box.
Correct, right. So a solid has its own shape, but a liquid takes on the shape of its container, okay? So how are the molecules in a gas different from those in a solid? So look at your notes and look at your gas particles and look at your solid particles. How are gas particles different from those in a solid, Josie?
Solids like stay still and gases like just float.
Right, good job. Does anybody else have anything else to say?
Gases
Okay, Noah?
Gases can move more than solids can because gases, if it didn't have lid on it, they can escape and solids can't escape.
Right, good job.
solids are fixed.
Right, solids are fixed. Good job. Gas molecules are not rigid and have no definite shape or volume, while solid molecules are rigid and have a definite shape and volume. Okay? So, think about this. Can water change its state of matter to be solid, liquid, and gas? Josie?
Yes.
Yes, they can. Can you tell me how?
Because if the water freezes, it can turn into ice,
Right, which is a
solid.
right. Good job. What is the liquid form of water?
Liquid form of water is whenever you have like a bottle of water
Mhm.
and you pour it into like a glass.
Right, it's still water, right? It's
Yeah.
just water. That's the liquid form. Good job. So what about the gas form of water? Does anybody got any idea how?
Water vapor?
Water vapor. Good job. Good job. So yes, it can be frozen to a solid, melted back into a liquid, and then when it is boiled, the steam is water vapor. Okay? Alright, so this is the part where I asked two friends to look up some definitions for me. These are two other states of matter. Okay, so Josie, will you read us what a colloid is? Yeah, colloid, sorry. Colloid is.
Colloid is a combination of molecules mixed through other substances that will not settle out or join with the other substance.
Good job. So a colloid is a mixture of one substance spread out evenly inside another substance. They can be in two different phases or states of matter. That means that it can kind of be a liquid and kind of be a solid, or kind of be a gas and kind of be a liquid, okay? So some examples of this would include whipped cream, mayonnaise, milk, butter, gelatin, jelly, muddy water, plaster, colored glass, and paper. So that means that they have two parts put in one. So here's a picture of an example of that. This is mud, which is dirt and water, okay? That's two things put together to make one. That's a colloid.
Mixed mud.
Good. Okay, so my other friend is going to read what plasma is.
Plasma, to put it very simply, a plasma is an
Ionized.
ionized gas. A gas into which surface energy is given to free electrons from or
Atom or molecules.
to allow both species
Ions
and electrons to
coexist. Good job, thank you. So plasma is known as the fourth state of matter, a very hot gas that has a lot more energy than the other three states of matter. Just like your parents put fuel in their car, energy gets added to gas, heats it up, and energizes it to create plasma. Okay, plasma is the most common state of matter in the entire universe. We see it here on Earth in the forms of things like lightning and the northern and southern lights. Okay, you guys read about the northern lights earlier, right? This is a picture of the northern lights.
That's in California.
Alaska. to make fluorescent light bulbs and the plasma televisions you watch cartoons on. Even our sun and most of the stars are big balls of plasma. Okay, so can you guys tell me an example of plasma? What is plasma?
Northern Lights.
Good job.
The sun?
The sun, good job. Southern lights, good job. What about a colloid? Who can tell me an example of a colloid?
Death? No.
No, not quite, that's a solid. Can you tell me an example of a colloid?
Whipped cream.
Whipped cream, good job. Okay, so we're gonna move on. Okay, so this is the part where you guys get to get up and move. So I need you all to come up here and line up shoulder to shoulder for me, and we are going to demonstrate the molecules of matter in a solid.
Where I go?
Right up here, shoulder to shoulder. Shoulder to shoulder. And you guys are just gonna kind of move back and forth a little bit. This is what molecules in a solid feel like. You kind of bump in shoulders a little bit. That's it though. You can't, okay, not too much, not too much. Molecules in a solid can't really move. They just kind of vibrate, just barely. Okay? So this is what the particles in a solid look like. All right, so now we're gonna demonstrate the molecules in a liquid. Okay, for this, we're going to say that the room is halfway full of liquid, and you guys are going to walk slowly around and come back and forth, and you can kind of bump into each other, but you just kind of walk past, okay? So halfway through the room and walk around. This is what the particles in liquid look like.
Abby, your mom's gonna pick you up at 2:15.
Okay.
Go. Halfway. Don't go past these row desks. Just kind of bounce around and move like the molecules in a liquid. Not hard, not hard. Okay, you gotta fill up the whole space of the liquid. So over in the corner. Good job. Okay, now come back to the front. And we are going to demonstrate the molecules in a gas. Okay, now this time we are gonna walk more quickly, but we are not gonna get crazy. Okay, and we're not gonna run into each other and hurt each other. Okay, so when you make contact with another student, if me and JJ make contact here, I'm gonna go the opposite direction of JJ, and he's gonna go the opposite direction of me, and we're gonna keep going until we run into another object. And then you'll go the opposite direction of that object, okay? And in a gas, we fill out the entire space available, right? So we're gonna fill up every corner in the room. Okay, go.
I can't do these. The space.
Careful. Now go the other way. Go the opposite direction. All right. Okay, guys, now you can have a seat. Thank you for helping me demonstrate the molecules in solids, liquids, and gases. Okay, now comes the fun part, guys. We're gonna divide up into groups. Okay, so our groups are gonna be in rows of tables. So this is my first group, second group, and third group. Okay, we are going to be making a substance called goo. Okay, now I need you guys to, amongst your group, discuss this. Somebody needs to be the person that's going to pour the cornstarch. Somebody's going to be the person who pours the water carefully so we don't make a mess. Somebody's going to be the person that stirs. And then somebody needs to be the person that takes notes, because you're going to have to answer these two questions. Okay? need everybody to take part, okay? Okay guys, so the first step is to pour the cornstarch into the mixing bowl. Yes, the entire amount. It's the bag with the white stuff. That's the cornstarch. Pour the entire amount into the bowl. Be careful because it will make a mess. Okay, so the next part is to slowly add the water. Make sure you get it in the bowl, guys. Okay, and then the person that can supposed to stir, you can go ahead and stir. It's kind of hard to stir, so it's going to take some muscle. Be careful that you don't slip and push the cornstarch everywhere out onto yourself. Okay, and somebody needs to take notes and answer these questions. What do you think the molecules in goop look like and why? What state of matter do you think goop is and why? So remember, our states of matter are solid, liquids, gas, colloids, and plasma. Okay? Don't get your hands in it. Try to use just the spoon, because...
Oh, how are you gonna take our notes?
Just put it on.
Miss Starr. This is stuff for like if you put your hands slowly, it's a liquid, and if you
I don't know.
my stepmom she made a thing where if you put your hands in fast, it's solid, and then if you slowly put it in, it's a liquid.
Well, maybe. Stir it up, guys. Do you need help? Just on the back of this is fine. Just one person needs to. Just right here. You just need to answer. You need to discuss in your group and answer these two questions and write your answer down. Okay? The goop is the stuff you're making.
You have to answer the smells for you.
Will you have to keep it?
Maybe. Okay, stir, stir, stir. You will get to play with it, but you don't need, we're gonna pour it in a bag to play with it though.
Like when we in the whole group, will we all get some?
Well, it doesn't, it's not like putty, so it,
Putty sticks to your
yeah, you gotta use a spoon.
Is it kind of like slime?
It's kind of like slime, but not quite. Its properties are different. That's why they call it goop. I'm not gonna tell you a whole lot about it. You guys gotta figure it out.
She was from that. We have to discuss what you think the answer Miss Starr, do we have to discuss with the group what we think the answer is?
Yes.
How do you spell goop? You have to write the answers down too.
Stir it. Okay, you guys need to talk about it. Yes, you've got it. Right how it's supposed to be. Look at it. See, watch. Is that a liquid? Do you think it's a liquid? What do you think that is? What is it?
What do you think this is?
Did you get it? Got it working?
But I think it's a solid. If you try stirring it, you can see what.
I'm not playing with slime.
Well, you don't have to play with it.
What do you think?
You got some of it.
It's solid because if you stir it,
Luckily, it'll just vacuum up.
and like say
Okay, look at it, guys. Is that a liquid?
yes.
Are you sure? I'm not gonna tell you. You figure it out.
Okay, how do we know? Wait, hold on. It's a solid and it's a solid. I know it's a solid for sure, and I think it's a solid too.
Okay, remember your choices are solid, liquid, gas, colloid, or plasma. answer what it is. Ready? Are we watching?
We get to have some hard.
No, it should be properly. Cause look. No, don't even touch it. It's not slime though.
It's a liquid.
It's solid. We have to have one answer though.
I can't tell you what it is. Here's some that I already made, guys. You can, if you're gonna have to mix it up though. So fill it and
Have the blue.
squish it. You're gonna have to squish it and feel it to get it going back to its original form. Okay? You have to squish it.
Like yours, guys.
Have to squish it. Make sure you get the lids closed good. You have to squish it good. Okay, now ready? Here, hold this. What? Now, guys, look. Watch this. This stuff made real good. See, look. You can't really scrape it, but it will pour.
This, because I think it's a solid.
Is it a solid? Look at it.
Yeah, but like.
Is it a liquid? Are you sure?
It's not sticky at all.
It's a solid and a gas. It's a solid.
Okay. Well, if it's two, what's it called? Don't get your fingers all in it.
It's not so much.
It's okay. It'll dry in just a second, and it won't be wet. No, it fixes it back.
Whoa,
Don't we pour this in there?
Put one finger. The bottom is
Did you get this all going again? Look, watch it, guys. When you dump it in the bag, is that a liquid? Look. Are you sure that's a liquid?
But if you let it set and then touch it, it's
This hill.
So what is it?
It's a solid.
Is it a solid?
it's a solid and
Is it more than one?
yes, it's a solid and a liquid.
Well, what's that called?
Plasma.
Ours is starting to get hard.
Tip in.
Ours is solid.
No, no.
This part. How is he changing?
Your size.
Okay, stop. Liquid, and then the bottom, it's so hard. Do this. It feels like coffee tap. It's a liquid and solid.
It pours like a liquid.
And it's hard like a solid.
Hard like a solid.
Guys.
Liquid and solid.
Well, what is that called?
Matter.
Colloid.
Yeah.
Okay. All right, we're going to take a few minutes and we're going to clean up our mess. Okay? We'll get a paper towel or some, whatever we can get, and clean up your table.
You can't be stingy.
Thank you. Okay, have a seat back at your desk. And pass it around in your group and let everybody feel it.
No, pass it down.
Let everybody feel it. Move the bags around, guys, and look at them. Clean up the mess that's on the table. Okay, and amongst your group, decide on what it is. What do you think that is? Is it a solid? Is it a liquid? Is it a gas? Is it a colloid? Is it plasma? Okay, so make sure you answer your questions. Okay. All right, guys, so I'm going to pass out an index card. And you all are going to answer and describe to me what each state of matter is without using your notes. You're going to tell me what each state of matter looks like without using your notes. A solid, liquid, and a gas?
Do you have to draw it?
No, just tell me what it looks like. Well, I guess you could draw it if you want to draw it. But also tell me about it. Tell me what a solid and liquid and a gas looks like. I'm gonna give you 5 minutes to do this, guys. Tell me about a solid, a liquid, and a gas. Remember, what are its properties? What can it do? What do we draw? Did you write the properties of a solid and a liquid and a gas? Remember? Can a solid change? Can a liquid change? And if it does, how does it change? Make sure, guys, that those lids on those Ziplocs are tight. Because if not, you'll make a big mess. Just describe it to me. Remember, what does the molecules in a solid look like?
together and can barely move.
Right, exactly. Anybody else? No? Okay, so the particles in a solid are rigid, they have a fixed shape and a fixed volume. That means that they do not change, right? Does everybody get that? Okay, so what does the molecules in a liquid look like?
They're kind of, they have room, but they're not like really free. They can move, they can kind of move.
Right, they can move. So they're not rigid, they can change shape, right? How do they change shape? They take on what? A shape of,
Matter?
it is matter, the shape
The
is what?
shape of the container.
Right, good job. The liquid takes on the shape of the container. Good. So they do not have a fixed shape or a fixed volume. Okay? What about a gas? What do the particles in a gas look like?
They go out of the bottle and
If it doesn't have a lid, right?
You can't see it in
Molecules, no, you can't see molecules with your naked eye. Okay, so they're not rigid. Okay, they have no fixed shape and they have no fixed volume. That means exactly what Emily said. That means if you put them in a bottle that doesn't have a lid, they're gonna come out. Okay? Okay, so we're going to talk about your discussion questions. Okay? So what do you think the molecules in goop look like? Do you think they're moving fast? Do you think they're moving slow? Are they moving at all?
I think they're moving kind of slow.
Kind of slow. Okay, what do you think, Noah?
We think that it is a call.
Okay, that's not quite what I asked you though. I asked you about the molecules. How are they moving?
Oh, they're moving like kind of fast and slow.
Okay, so in between.
I
Yes,
think
Gigi?
they're moving fast.
You think they're moving fast? How do you think they're moving? Slow. Okay. How do you think they're moving?
I think they're moving in between because at the bottom it's hard and at the top it's moving.
Right. Good job. Okay, good job. So what state of matter do you think goop is? What do we think?
Solid.
You think it's a solid? Okay.
Colloid.
A colloid? What do you think it is? A colloid? Who else?
Colloid.
A colloid? What do you think?
Colloid.
A colloid? Okay, so why do we think it's a colloid?
Because it's kind of hard and kind of gooey.
It's kind of gooey, so it moves around a lot, so it's kind of in between, right? It kind of looks like a liquid, and it kind of looks like a solid, and kind of feels like a solid, right? Okay, goop is a colloid. So if you guessed colloid, you are correct. It's an in-between state of matter because its properties it has properties of a solid and of a liquid. Some examples of these colloids are butter, shaving cream, lotion, and ketchup. Okay, so can you guys think of something else that could be a colloid besides goop? Putty, right? You know? Slime could be, okay, so, because a colloid is two things put in one, right, to make something else.
It's like a
Water and dirt make mud.
Right, good. Water and dirt make muddy water. Good, good job. So, I think that's it for me, guys. Did we have fun?
Yeah.